Good morning, everyone. Welcome to Thursday, March 19th, and day 2 of distance learning. So I saw a lot of you were active on IXL yesterday. There were also some confusion about how to log in. So I've sent out another email with the actual URL that takes you to the Kennedy login page. If for whatever reason you're having issues logging in, talk to me now, because there's only going to be more and more IXL codes as we go through. I want to make sure you have the opportunity to get those done. Just a reminder, all IXL codes are due tomorrow by midnight, well, like 11:59 p.m. or something like that. All right, so it is a new day. It is a beautiful day. I'm wearing my Jar Jar Binks Star Wars shirt, and today we're going to warm up with a review of what we did yesterday. So I'm going to have you multiply these two binomials. In number 1, you're going to multiply x plus 7 times x plus 5. And in number 2, x minus 3 times x plus 6. You can use the area model, so the box method, which you just create a window, or you can use double distribute. Go ahead and pause the video now and try these on your own. All right, when you unpause, here we go. So I'm going to do double distribute on the first one, and I'll do area model on the second one. Again, you could have done area model on both or double distribute on both. It wouldn't change the answer. So just a reminder, double distribute, I'm taking the first term from the first binomial and I'm multiplying it by the entire second binomial. So that would look like x times x plus 5. That's step 1. Step 2, I'm taking the second term from the first binomial. So we took x and multiplied it by the entire second one. Now I have plus 7, that's the second term, and again multiplying it by the entire second binomial. X plus 5. So there you see the x plus 7 is right there, and the x plus 5 is being multiplied. Now it's called double distribute for a reason. We're going to distribute twice. We're going to distribute here and here. So here we go. X times x is x squared. X times a positive 5 is a positive 5x. So our first distributing is done. Positive 7 times x is a positive 7x, and positive 7 times 5 is a positive 35. Now, if you remember, 90% of the time when we multiply two binomials, your answer is going to be a trinomial, which means 3 terms. This is a polynomial with 4 terms, so you might be thinking to yourself like, how do I change it into 3 terms? Well, it's as easy as, you got it. I'm just assuming, by the way, that you're giving me the right answer. You're going to combine these like terms, this positive 5x and the positive 7x, which, as we know, combines to a positive 12x. So your final answer is x squared plus 12x plus 35. This is called simplifying. If you remember, simplify means do the math. So because this is multiplication, we're doing the multiplication. It's just a little bit different when you're doing it with binomials than like your normal 12 times 3 type of multiplication. So that was the double distribute. Now again, if you did the area model or the box method, you still should have x squared plus 12x plus 35. It just obviously looks a little bit different. So I'm going to do area model on number 2. So if you remember from yesterday, area model, we start with a window. So I'm going to start with a window. Perfect. Draw a little window. Okay, now the first binomial is going to go, it actually really doesn't matter. It could go across the top or it could go down the side. I'm going to put it across the top. So I take x, and I'm going to bring the minus along with the 3 because we're going to look at that as a negative 3. Then I'm going to take the second binomial and put it on the side, x and positive 6. Now, if you remember, area model is basically just find the area of each individual square. So what is x times x? That's x squared. X times a negative 3, negative 3x. X times a positive 6, positive 6x. And I will bring that positive sign along with it, because when you pull it out of the expression, you want to understand that that's actually an addition sign. And then the positive 6 times the negative 3 is the negative 18. Commonly made mistakes are with your positives and negatives, so just make sure that you're taking your time to actually think about those. Now, rather than take this entire expression out, because you can't just leave it in the box, like it should look something like this when we're done. Rather than pull out each individual term, I'm gonna pull out the first term, which is the highest degree, x squared, and then like I showed yesterday, I'm gonna combine the like terms in the box. So if I pull out x squared, that's my first term because it has the highest degree. Then I'm just gonna combine these two because I notice that they are like terms and they can be combined. So this is a negative 3x plus 6x, or if that doesn't make sense, it's just a positive 6x minus 3x. Like you can read it in either way. 6x minus 3x is a positive 3x, and what does that leave us with? Our final term, which is our constant, minus 18. That's your final answer. Again, what do we call this? We call this simplify, because simplify means do the math. So again, I wasn't expecting you to do the first one with double distribute, the second one with area model. You should be doing what works for you at this point. Now, today we're going to learn factoring. This is a crucial skill that you need to have in Algebra 1 to be able to do Algebra 2. Now, with factoring, it's basically simplifying in reverse. So we're gonna start with something that looks like this, and we're gonna end with something that looks like this. So we're gonna start maybe with the trinomial and end with the product of two binomials. I know, I can just sense how excited you are that we're about to do this. So without further ado, let's go ahead and get started. So on your notes, you can just kind of follow along here. We're looking at factoring trinomials. Where did I put my pens? See, it's just like regular class. I can't find where I put my stuff. It's weird. I'm gonna pause the video here real quick. Aha, I found them. Okay, so again, factoring trinomials. So to factor means to write as a product, which we remember from CC3, a product means multiplication. So if I said, quick, factor 12, you could potentially say 3 times 4, you could say 6 times 2, you could say 12 times 1. That's called factoring a number. Take the number, write it as a product. When we're factoring, we're going to be factoring trinomials, which, as you remember, is a 3-termed expression. So here we go. Now, it may seem a little weird at first, but you'll be able to catch on. We call it the P's and Q's game. So let's take, for example, and this one might look a little familiar because we kind of looked at it in our warm-up. Here's example 1. We're going to factor x squared plus 12x plus 35. Now remember, to factor a trinomial means to write it as a product of two binomials. So what I like to do is I like to set up what my answer is going to look like before I actually do it. So I know it's going to look like this. And there's going to be something, 2 terms here and 2 terms there. That's just what I like to do. You don't have to. Okay. This is where it gets a little bit weird, but you're gonna follow along just fine. We're gonna play the P's and Q's game. P's and Q's means we're gonna find 2 numbers that have a specific sum and a specific product. So if that doesn't make any sense, let me explain. You're gonna find 2 numbers that have a sum of 12. Now, before you start thinking about numbers that have a sum of 12, like 10 and 2, and 9 and 3, and 8 and 4, etc., those same 2 numbers must also have a product of 35. So when you play this game, it's easier to think about the product before you think about the sum, because there's tons of numbers that you can add up to 12, there's only so many whole numbers you can have that are a product of 35. So I'm gonna come over here. So to play this game, I'm thinking to myself over to the side, what plus what equals 12, that when I multiply the same two numbers equals 35. So thinking about like products of 35, so like 35 times 1. Well, 35 times 1 works, but does 35 plus 1 equal 12? No. So what about 7 and 5? Does 7 times 5 equal 35? Yes, it does. Does 7 plus 5 equal 12? Yes, it does. We just found our P's and Q's. So I'm just going to put those off to the side so that we know 7 and 5, 7 and 5. Now you're probably thinking, like, what on earth is going on? We're going to take what we just found and put it into two binomials. Go back over here. So, ready? Here we go. Think about it like this. When we multiply two binomials, the first two terms have to equal x squared. So you think to yourself, what times what is x squared? X times x, right? So our first two terms are x and x. Now, the second two terms have to be what two numbers multiply to 35 and add to 12. We just found those over here. They were positive 7 and positive 5. And they could also be switched. So if you wanted to put positive 5 first, positive 5 first, positive 7 second, you could totally do that as well. This is called factoring. Now, if you don't believe me that this is actually equivalent, I totally agree with you. I just want to remind you what we did as a warm-up. If you look at our first warm-up problem, we multiplied x plus 7 times x plus 5 and ended up with x squared plus 12x plus 35. Over here, we started with x squared plus 12x plus 35 and ended with x plus 7 and x plus 5. So they're equivalent. The only difference is this is called multiplying or simplifying. This is called factoring. All right, still don't believe me? That's perfectly fine. We're gonna look at another example. So that was example 1. Let me grab a different color here for example 2. So let's take example 2. And we'll do a little bit more practice with this as well, so don't freak out if you have no idea what's going on. Example 2. Okay, I'm gonna give you another trinomial, and you're gonna play the P's and Q's game to factor it. So let's say the trinomial I give you is x squared plus 3x minus 18. X squared plus 3x minus 18. So remember, when we factor, the first thing I like to do, and again, this is totally optional, you don't have to do this. I like to set up what my answer is going to look like. I know my answer is going to be a product of two binomials. And really, I actually also know something else. I know that the first term in both of these binomials is going to be x, because x times x is how I get x squared. So I'm just going to set up x and x. And that's all I know at this point. I don't know anything else. So don't get overconfident and start filling in something else. Here we go. Time to play the P's and Q's game. So again, it's what two numbers have a sum of 3. And please don't start thinking about this sum yet. It's really not about the sum. It's about the product. Like, for example, you might be like, 2 and 1 are the only two numbers that have a sum of 3. That's not entirely true. So think about the product. What two numbers have a product of negative 18? Okay, so we're going to come over to the side here. And we're going to play the P's and Q's game. So here we go. What two numbers have a sum of 3 and a product of, now notice I said negative 18. Why do you think that is? Because of this subtraction symbol here. Okay, so negative 18. In order to have a product of negative 18, one of these numbers has to be positive and the other one has to be negative. But then they also have to add up to 3. So we start thinking to ourselves, like, what times what is 18? How about 9 and 2? Well, 9 times negative 2. Well, what's 9 plus negative 2? That would be 7. not 3. And -9 plus +2 would be -7, also not 3. So 9 and 2 don't work. What two numbers have a product of -18 and a sum of 3? So in other words, they're only 3 away from each other on a number line. What about -6 and +3? Well, if it was -6 and +3, that equals -18. But -6 plus +3 is -3. So I feel like we're really close. How could we make it +3? What about +6 and -3? Let's see, +6 times -3 is -18, check one. +6 plus -3 is 3. So our two numbers are, let's see if I can do this, +6 and -3. So what do we do with those? If you remember, those are the second terms in our binomials. So again, we come over here and we're gonna put +6 and -3. Now, if you don't, and again, -3 could have gone first, +6 could have gone second. That's our answer. Now, again, if you don't believe me, if you're sitting there like, I don't know, that seems really weird. What is she thinking? What is she talking about? If you look at our second warm-up problem, it was x minus 3 times x plus 6, and it ended up with x squared plus 3x minus 18. All we did here was the same process in reverse. That's it. That's all that we did. So, as our little exit ticket, I'm going to give you 2 trinomials to factor, okay? So 2 trinomials to factor. So kind of letting that all sink in. So we're playing the P's and Q's game, and that part is going to be probably one of the hardest parts of this, is just getting to play the P's and Q's game. Some of us are really good at it, and some of us just need a little bit more practice. So, oh, we're not multiplying binomials anymore. No, no, no. All right, this is our exit ticket. Pretend that says exit ticket. I'll cross it up. Exit ticket. Factoring trinomials. All righty, here we go. Okay, number 1. How about x squared plus 9x plus 14. I just made that up. I should probably have had that in my head originally. X squared plus 9x plus 14. So again, I'm looking for a product of 2 binomials. So feel free to pause the video to work on this one first. I'm going to go ahead and put up number 2 as well. Number 2, x squared minus 4x minus 12. Yeah, that works. Remember number 2, product of 2 binomials. All right, go ahead and pause the video now if you want to try these on your own, playing the P's and Q's game, and then you can unpause when you want to see the answer. All right, if we unpause, here we go. Now, I just made these up, so I really hope that they work. Otherwise, that would be embarrassing. All right, to play the P's and Q's game, remember, if you want to start it off, you know that the first 2 terms are going to be x and x, because x times x is x squared. Now, we play the game. What 2 numbers have a sum of 9 and a product of 14? Don't try to think about the sum, think about the product. So off to the side, maybe you're thinking what plus what equals 9, that when I multiply them together equals 14. Okay. Product of 14. The only 2 numbers that come to mind for me are 2 and 7, but always remember 1 goes into everything also. So if 2 times 7 is 14, does 2 plus 7 also equal 9? Yes, it does. So our P and Q are 2 and 7, or 7 and 2. Totally works as well. So are we done? No, we're not done. We haven't finished our product of 2 binomials. So what are we going to do? We're going to put in our second 2 terms. X plus 2, x plus 7. Now, when you're doing your IXL code or your worksheet practice, it's always a good idea to go back and multiply to check, because otherwise you don't know if you're doing it right. So before I go on to the next one, I'm just gonna really quick multiply to check. And I'm gonna do double distribute to multiply to check. So here we go. X times x plus 7. It's kind of a funky looking x. So I just took the first term, multiplied, plus 2 times x plus 7. Here we go. I'm going to do this a little bit quick just because of the amount of time. X times x is x squared. X times 7 is 7x. 2 times x is 2x. 2 times 7 is 14. Combine like terms, you get x squared plus 9x. Can you still see that? Yes, you can. Plus 14. Now, how do I know if that's true? Is this what I started with? X squared, 9x, 14. Yes, I know that I factored correctly. So if you want to be sure that you did your factoring right, go ahead and multiply to check. And again, multiplying, as we saw in our warm-up, just means double distribute or area model. All right, if you'd like to pause the video now because you want to try the second one after seeing the first one done, go ahead and do so now. All right, here we go. So in the second one, I'm going to set up my first term. What times what is x squared? X times x. And if this was a different variable like b, then it would just be b and b, or a squared would be a and a. Now I play the game. What two numbers have a sum of -4? Subtraction symbols are negatives in this sense. And have a product of -12. So let me get down here. Alrighty. So what plus what is -4? That when I multiply is -12. Now remember, don't sit there trying to figure out the product. It's not going to work very well. Don't try to figure out the sum, figure out the product. What times what is -12? So like I think of 4 and 3, but 4 and 3 are only 1 away from each other, so they can't have a sum of -4. That's just impossible. I also think of like 12 and 1, but 12 and 1 are 11 away from each other. That's also not going to be a sum of -4. So what am I forgetting? How about 6 and 2? So 6 times 2 is 12, and 6 and 2 are 4 away from each other. So now it just becomes which one is negative and which one's positive. Well, I'll give you a little hint. If the sum is negative, that means the greater of the two numbers is negative. Let me show you what I mean. If I made this +6 and -2, what's +6 plus -2? +4. Why? Because the greater number is positive, so the end result has to be positive. So this doesn't work because that's +4. So how do I make it -4? You just switch the negative sign over to 6. -6 plus 2 is -4, check. -6 times 2 is -12, check. Why do we do all that? Because we need to figure out what our second term is in each of our binomials. So here we go, x minus 6, x plus 2. And you can always switch +2 and -6. Now, don't take my word for it. Let's do a quick check. It's always good to check your work. You know that if you've been in my class. Here we go. We're going to do box method on this check. Let's squeeze it in here. All right, across the top, x minus 6, down the side, x plus 2. By the way, you can always pause at any time if you want to do your check on your own. X times x, x squared. -6 times x, -6x. X times +2, +2x. -6 times 2, -12. Let's see. That leaves us with x squared. Combine these two. -4x minus 12. Is that what we started with? Yes, we did it correctly. So again, this whole thing is called factoring using P's and Q's. So attached to this will be some worksheet practice with a full answer key. So the beauty of having a full answer key is that you don't have to necessarily multiply to check. You can just look and see if you got it right. In the IXL, I do highly suggest that you multiply to check because you guys get frustrated with IXL sometimes because you get the wrong answer. Always multiply to check if you want to be sure. All right, so just a reminder, IXL codes are due tomorrow. You have the multiplying binomials, which hopefully now we feel a little bit more comfortable with, and the factoring. And I'm not going to post a new instructional video tomorrow, but I will post a warm-up video going over factoring again, just in case you're like, no idea what she just did, I need another practice. So tomorrow morning, I will do a warm-up video, but I won't introduce anything new. Hope you have a wonderful rest of your Thursday. It looks like it's a beautiful day outside. Maybe just open up a window, get some fresh air, and I'll see you tomorrow. Bye-bye.